All right, so on these questions, these are solving systems of equations and inequalities. You'll need this when you go to do some of your quiz questions, and it's going to be helpful if you can know what these are. So this first one is a circle, okay? This next one is an ellipse. They are very similar. The only difference is on the circle it's equal to a number other than 1. On the ellipse you have these fractions, but you do these problems similar, okay? So the way you do these problems, the easiest way is to graph, okay? So I pull up my grid. The first thing you need to realize is that the numbers inside the parentheses are the coordinates of the center, okay? So we're going to have a graph. So here we go. So there's my graph, my grid, my coordinate x and y axis. So the center of this circle is just opposite of these. So my center is at -1, +3. So I come over here, -1, +3. That's the center. So it's always backwards of these numbers in here. And the one with the y goes with the y. The one with the x goes with the x. So -1, 3 is my center. This is the radius squared. So to just get the radius, so since this is the radius squared, that's the radius squared. So just to get the radius, we take the square root of that number. So the square root of 16 is 4. So the radius is 4. Meaning from this dot, I'm going to go 1, 2, 3, 4 in each direction. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And this is a circle. Okay? If you want to see a nice pretty circle, I can cheat. I should show you how I do it freehand so that you don't feel so bad when your circles don't look as pretty. So anyways, there's my circle. Okay? So now the next one is an ellipse. Like I said, very, 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 very much the same thing. The only difference is this part. Okay? So again, the center is still opposite of these. So the center is still -1, +3, opposite of these. So -1, +3. Well, I'm already there. But now instead of taking the square root of this number, you take the square root of these numbers. Okay, so the square root of 16 is 4. This tells you, since it's with the x, how far left and right you go. When it's with the y, which this one is, the square root of 4 is 2, that tells you how far up and down it goes. So values with the y tell me up and down, values with the x, left and right. So x, left and right, 4. So there's 4, there's 4. The y, up 2, down 2. So an ellipse is an oval, it's a football, it's a, I don't know, whatever you want to call it. Flattened egg. So that's my ellipse. Where do these points intersect? Well, they intersect 1, 2, 3, 3. So 3, 3 is one solution. Where does this one intersect? It intersects at -1, 2, 3, 4, 5. So -5, 3. That's another solution. Okay. So 3, 4, 5, 1. So once you've done that, you've done the work for this problem. Okay. So anyways, that's what it looks like. All right, so on this problem, this is a circle again because it doesn't have fractions and it's equal to a number at the end. And they're both squared with a plus between them. So those are criteria for a circle. Both x and y have to be squared. It has to have a plus between them, equals a number over here. So since there's nothing here, it's like I have x plus 0 squared plus y plus 0 squared. So really we're saying the center is at 0, 0. So the center of my circle is 0, 0. The radius is the square root of 9, which means I go, square root of 9 is 3. So I go up 3, right 3, down 3, left 3. Okay. I connect those dots. Okay. Now, the next one says that I have y equals x. It's a beautiful circle. Don't make fun of it. The next one says I have y equals x. So that's in y equals mx plus b form. So the b is 0. M is just a 1. So I go up 1 over 1, up 1 over 1, up 1 over 1. And you can continue that up 1 over 1 forever until you get tired of thinking up 1 over 1. Okay, so that's the circle. Now, where do these points cross? Well, this one crosses about, 2.2 and 2.2. This one looks like it crosses about negative 2.2 and negative 2.2. So that's what I put for my answer, and there it is. Those are my solutions. That's the x and y coordinate. The next one, this is an absolute value. Anytime you have y equals, you can just go to your calculator and type that in. Okay, so y equals 1/2 x plus 3 minus 2. So y equals 1/2 absolute value. So if you hit math, go over number, abs, x plus 3, and minus 2. Minus 2. Graph. So here's what my graph looks like. Looks like it has a center right here at 1, 2, 3, negative 2. Now to get some better ideas on those dots, if I hit second graph, there's my table. And sure enough, there's that point, negative 3, negative 2. And then negative 5, negative 1, negative 7, 0, 1, 0. So I'm going to come and put that on this table. Negative 3, negative 2, negative 5, negative 1, negative 7, 0. So that's 3, that's 5, that's 7. 1 at 0. Connect my dots. There we go. So there's my absolute value. Now the next one's an ellipse. So the way I know it is an ellipse is because I have x and y are squared. It's a plus between them. It equals 1, and it's divided by something under here. So the center of this is at negative 3, 1. That's the center. Remember, it's always backwards of those numbers. Okay? So I put those on here. Negative 3, positive 1. Now the x direction says I go the square root of 16, which is 4. So I go 4 that way, 4 this way. The y direction is 2. So I go 2 and 2. I connect my dots. So it looks like it might cross about there and about there. Now realize, I hope I do better on your quiz than this so that you can actually see for sure if they do cross. But that's about negative 5.1 for the x and about negative 0.8 for the y. This one looks like, about negative 6.5 and, negative 0.3. So that's my xy coordinate. Those are the xy coordinates that are my solutions. So the solution is where these two graphs intersect. Okay. So that's saying that this x and this y will be a true statement for both of these equations. Okay, question number 4. A little bit hard to see those colors. But again, this is an ellipse because I have an x squared plus a y squared. It's divided by something that equals 1. There's no numbers with the x and y squared, so that means my center is at 0, 0. So I put a dot at 0, 0. The square root of 4 is 2, so this is with the x's. So with the x's, I go 2 each direction. Kind of curious, had a thought. Okay. I had thought that maybe I had my y's and x's backwards last time and I did it backwards, but I didn't. Square root of 16 is 4, so that's under the y's. So I go up and down 4. 1, 2, 3, 4. So now I make a picture the best that I can. It's not going to be the best, but you know what? You can have the computer do it, but I'd rather have you do it and make it look sloppy than have the computer and have it all pretty. So anyways, now we have, if I solve this for y, I'd minus x squared over here. So I saw that this was just a plain old y. And I was like, hey, I could get y alone. So I get y equals negative x squared plus 4. So there's a y equals. I can go to my y equals, come to my calculator, type in negative x squared plus 4. Hit my graph. There's my picture. Come on, picture. Crosses at 2 and negative 2 and up there at 4. So, boy, that gives me some good points. 4, negative 2, and 2. Kind of looks like this. Maybe not quite that wide. Come on. A little prettier than that would be better, but you know, you get the general idea. So where does this cross? Well, they cross at 0, 4. They cross right here at 2, 0. And it crosses right here at negative 2, 0. So those are my 3 solutions for this problem. All right, this one, it's a y equals. Well, I'm going to go to my calculator. I'll teach you how to do it without a calculator. This is the center, 3, 5. Okay, it's a parabola. Inside the parentheses is opposite, outside is the same. So I go up, I go right, 3, up, 1, 2, 3, 4, 5. Now, you're going to plug, think of having 1 squared, then 2 squared, then 3 squared. That's how far you go from the center. So when I go left, I'm going to go 1 squared each direction. I go left 2, so notice how my x is going 2 away from the middle. That's this 2 squared. My y is going to go 4 away. And it's symmetrical. I go 3 away, so I go 9 down. 5, 6, 7, 8, 9. And it's symmetrical. Okay. The other way you could plug in these points, you could plug in 2. So when I plug 2 in, 2 minus 3 is 1. 1 squared is 1. Put a negative with it. 5 minus 1 is 4. So there we go. And then it's symmetrical. Plug 1 in. 1 minus 3 is negative 2, but negative 2 squared is 4. Put a negative with it from that. Negative 4 plus 5 is 1. Plug 0 in. 3 squared is 9. Put a negative with it. It's negative 9 plus 5 is negative 4, so there's that one. And it's symmetrical. So anyways, you can do it without a calculator. You can also type it in the calculator and get these same points. Now the next one, this is a circle. It doesn't have a fraction. It's a squared on both the x and the y, and it's a plus between them equals a number. So my center is at 3, 2, opposite of the sign inside. So I go right 3, up 2. Square root of 9 is going to be my radius, so that's a radius of 3. So there's 3 there, 3. I go 3 away from the center. Okay, so now I connect my dots to make a circle. I've seen better, but it'll do. So that's the center of my circle. This dot up here is right 3, up 1, 2, 3, 4, 5. So that's a 3, 5. This intersection point looks to be about right there. So that's 2, 4, 5.2, and negative 0.1. Somewhere like that. This one looks to be about right here. So that's like 0.7 and 0.6. So anyways, those are my intersection points. Those are my coordinates. That's my answers. Those are my answers. Okay, so that is how you do that problem with the solutions you have 3 different ones on this problem. Okay, so hopefully that'll help with the Canvas quiz.